Lesson 8.3. Today we will learn how to factor a quadratic equation with a leading coefficient of 1. So far, in lesson 8.1 and 8.2, we've learned how to factor. We've learned how to factor monomials and we've learned how to factor polynomials. In factoring polynomials, we learned how to factor out the GCF. This technique will result in two factors, a monomial and a polynomial. And then number 2, we factor out a 4-term polynomial by using the grouping strategy. And the result there is 2 binomials. Today we will learn how to factor a quadratic equation, a trinomial, with a leading coefficient of 1. And this will result in 2 binomials. We will use the product and sum, or PNS strategy, to factor a quadratic in the form of ax squared plus bx plus c, where a is equal to 1. So here are your steps. First, you must find two integers, and we'll call them m and p, whose product is equal to a times c, and whose sum is equal to b. Second, you're going to write the factors as follows. 2 binomials, so you will have x plus m times x plus p. Okay, this skill is going to take a little practice, but you'll note that the more you practice, the better you get at it. So let's start with number 1. Here is a trinomial, x squared plus 7x plus 12. And the directions will say to factor this trinomial. Well, I look at it and I note that there is no GCF. It doesn't have 4 terms, so I can't use grouping. So I'll need to try to factor this polynomial using the PNS strategy, or the product and sum strategy. Okay, so notice that the standard form of a quadratic equation is ax squared plus bx plus c. So let's first identify a, b, and c. In this problem, a is equal to 1, b is equal to 7, and c is equal to 12. Eventually you won't need to write that, but I just want to make sure that you know how to identify a, b, and c. Now what we need to find is, we need to find two integers that have a product of a times c, which is 1 times 12. So the product has to be 12, and their sum, when you add these two numbers, it has to be equal to b, which is 7. Okay, so we will try to find two numbers whose product is 12 and whose sum is 7. The first thing I note is that both of these, product and sum, are positive. Both are positive. Therefore, I know that both my integers must be positive. So perhaps you already know what the two numbers are, but just indulge me as I go through the process of testing, guessing and testing what the two integers would be. Okay, the two integers might be 12 times 1. But we know that 12 plus 1 doesn't give us 7. So the next two integers that I can think of are 6 times 2. But if I add 6 and 2, the sum does not equal 7. The next integers that I can come up with are 4 times 3, and so those are the ones that work, because 4 times 3 is equal to 12, and 4 plus 3 is equal to 7. So I found my two integers. Okay, so I'm ready to factor. And very simply, I set up my two parentheses for my two binomials. X is here and X goes there. And then I have plus 4 and plus 3. Quite frankly, the order of these two binomials doesn't matter. It could be x plus 4 times x plus 3 or x plus 3 times x plus 4. It's really all the same. Okay, let's try number 2. D squared plus 11d plus 24. Okay, so if I'm asked to factor this polynomial, I look and I notice there is no GCF. It doesn't have 4 terms, so I can't employ the grouping strategy. So I have to try the product and sum, or the P and S. Okay, so I know that my product has to be equal to A times C and the sum of B. Let's identify A is equal to 1. B is equal to 11, and C is equal to 24. So I need to come up with two integers whose product is A times C, or 24, and whose sum is equal to 11. Okay, so I'm going to set up my two binomials. I know D goes here and D goes here. And now let's think about what two integers fit into this description. You multiply them together and you get 24. You add them together and you get 11. I'll go through the guess and test strategy. All right, I have 24 times 1. Well, that doesn't work because if I add 24 and 1, it will equal 25. I've got 12 times 2, which does equal 24, but when I add them, I have 14. The next numbers would be 8 times 3, and those are the integers I'm looking for. 8 times 3 equals 24, and 8 plus 3 is equal to 11. So I found my two integers, and I can complete my factoring. So I have D plus 8, positive 8, and D plus 3, positive 3. Please note that you can always use FOIL to check that you factored correctly. So I'll do that now very quickly just to show you. Okay, I'm going to multiply the two first terms, that's D squared. Then I'll do the outer terms, that's plus 3D, the inner terms plus 8D, and the last terms plus 24, and then I will simplify. D squared plus 11D plus 24, and I can make sure and check that I get right back to my original quadratic equation. Okay, number 3. Number 3, I have 9 plus 10t plus t squared. Okay, please note that this is not in standard form. So in order to factor a quadratic, you first want to write it in standard form. So let's rewrite it in descending order of variable exponents. So I have t squared plus 10t plus 9. Okay, so again, I need to find two integers that have a product of 9 and a sum of 10. So let me set up my two parentheses for my binomials. I need my product and my sum. My product is A times C, that would be 1 times 9, which is 9. And my sum has to equal B, and that is 10. So let's guess and test two numbers that when I multiply them, they give me 9. When I add them, they'll give me 10. All right, so let's try 9 times 1. 9 times 1 is 9. 9 plus 1 is 10. I found them. 9 times 1, 9 plus 1, and there they are. So I can go ahead and finish my factoring. So I have t plus 9 and t plus 1. Okay, number 4. X squared minus 8x plus 12. Okay, so here it's already in standard form. There's no GCF. I can't use grouping. Product and sum is the only technique I can use. So I have 2 parentheses. It will result in 2 binomials. I've got x here and I've got x there. I need to find 2 numbers whose product is positive 12. A times c is positive 12. And whose sum is negative 8. Well, let's think about that. 2 numbers whose product is positive and whose sum is negative. These 2 integers must both be negative, because when you have a positive product, they have to have the same sign, and they add up to a negative. Therefore, both of my numbers are negatives. Let me guess and test and see what the 2 integers are. Okay, so we will try 12 times 1, and we'll try negative 12 times negative 1. Well, when I multiply them, yes, it's true that that equals 12, but when I add them, I get negative 13, so that's not right. Okay, the next 2 integers I have negative 6 times negative 2. When I multiply negative 6 times negative 2, it's true that my sum is positive 12, and when I add them, my sum is negative 8. So I found them. My 2 integers are negative 6 and negative 2. Negative 6 plus negative 2. So I can go ahead and complete my factoring. So I would have x minus 6 and x minus 2. Okay, try number 5 on your own. W squared minus 11w plus 28. Set up your 2 binomials. You know w is there, w is there. Now you have to find the product and sum and complete your factoring. Hit pause, and then when you have an answer, please come back and check. The factors are w minus 7 times w minus 4. Okay, number 6 we'll do together. Let's try this one. I've got y squared plus 13y minus 48. So in this problem, I can't factor out a GCF, I can't use grouping, and I'll always check for those first. So I know I need to use the product and sum strategy. So my product is 1 times negative 48, so that's negative 48. And my sum is positive 13, it's B, 13. Okay, so we will use guess and test to find our 2 integers. What I do notice here is that my product is negative. So I know that the numbers, one is going to be positive, one is going to be negative. And because my sum is positive, I know that the larger number is the positive one. Okay, so let's go ahead and guess and test what the 2 numbers are. All right, so my product is negative 48. It could be 48, negative 48 times positive 1. But the sum there would be negative 47. That doesn't work. I could have negative 24 times positive 2. Well, the sum there would be negative 22, so that doesn't work. 3 goes into 48 16 times, so it could be negative 16 times positive 3, and those are my two numbers. So I know that negative 16 times 3 is negative 48, and negative 16 plus 3 is not positive 13. So what's wrong with my thinking? Well, if you notice, my signs are wrong. It needs to be positive 16 and negative 3. The larger number has to be positive. So my factors are y plus 16 and y minus 3. Try number 7. Try number 7 on your own. Hit pause and then check your answer. Okay, please check your answer. The factors are r plus 4 times r minus 6. Okay, now we will solve quadratic equations again by factoring using product and sum. So step number 1, make sure your equation is equal to 0. Number 2, factor using product and sum or any other strategy that you know. And number 3, solve for the variable using the zero product property. Alright, we'll do 2 of these. Number 1, I have x squared plus 6x is equal to 27. Okay, my first step is to make this equation equal to 0, so I'll subtract 27 from both sides. I get x squared plus 6x minus 27 is equal to 0. Now I'm ready to factor this quadratic trinomial. So I know that I have x here and x there. I'm looking for a product and sum. Product is 1 times negative 27, so the product of two numbers is negative 27. The sum of those numbers is positive 6. When I guess and test, I come up with my two numbers. My two numbers are positive 9 times negative 3, positive 9 plus negative 3. So when I factor, I get x plus 9 and x minus 3 is equal to 0. Now remember, the zero product property says that if I have two terms multiplied together is equal to 0, one of them must be 0, both of them must be 0. So we set it up this way. X plus 9 equals 0. X minus 3 equals 0. And we're going to find the two roots, or the two possible solutions. So subtract 9 on both sides here. X equals negative 9. And we'll add 3 to both sides here. X is equal to 3. So my solution is negative 9, positive 3. Okay. Now try to solve number 2 on your own. Here we go. I have z squared minus 3z is equal to 70. So you want to solve for z. Okay, the roots of this equation are negative 7 and 10. Okay, here are some practice problems that I want you to do. These are simply factor the polynomial, so do number 5 and do number 15. And on this page you will solve. So go ahead and do number 1 and number 12. Remember to write down any questions that you have. We will continue practicing this in class tomorrow. And as I said, the more you practice, the better you get at it. So make sure that you practice this at home. Thank you. God bless you. Have a great night.